So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 345, and in this video we continue again with our move constructor example. Again here in CPP reference com we click on language, then there in the classes section to the move constructor, and we scroll here a little bit down to the example section, and we talked already about the first part here, and we go on with the next part here. And again I use the compiler explorer. Okay, and let's start here with the line 63. Okay, we make here just a C out, which is saying trying to move B. Okay, and in the next line we are creating a new object B1 with the struct B. I scroll up and see, yes, this is a struct, but this struct has this here. What is that? The answer is inheritance. So we are inheriting from A. And interesting is here, this is inheritance without the keyword virtual. So with other words, this kind of inheritance is not supporting polymorphism, but still it's inheriting all things what we have here. Okay, then let's go here and see what struct B got. Important, it's a struct. That means we have the access specifier public. And this one is also a public inheritance. How we can see this? When you go here, A is a struct and the access specifier for struct is public. So this is also a public inheritance, and everything here in the body is public by default. That we learned when we learned about the struct. And we have here now two variables, again a string and integer, like here on top, just with other names. So, and let's get started. We go now and create B1. All right, so we are creating this object B1, and what happens then? If we try to create an object like old time, a constructor must call, because creating an object means all this time constructor called. But interesting is when we watch here, constructor A is called, and the question is, why is not constructor B called? So let's jump again here to our struct B. First of all, what we notice is there is no constructor, but remember, the compiler can all time create an implicit constructor even if it's not visible here. Then the second question is, okay, why is the constructor then here not called? Again, we have inheritance. Inheritance means first the inherited base class will be constructed, and then the class itself will be constructed. So that means they call first this one here, this constructor here. Here we have a constructor user defined. This is this one here, and this one we have already talked. This will assign the values here and there, and then the compiler will try to call here the constructor, but you can see we have no explicit constructor here, so it is implicitly called and the constructor is default constructed. Okay, and let's go and construct this object B1. And when we construct an object like old time, the constructor is called. And the interesting part is here we will see that here the constructor A is called, but we are in struct B. So why is not the struct B constructor called? And the answer is because inheritance. We learned inheritance when we inherit from a base class. First the base class is constructed, then the class itself. So with other words, first the constructor of A will be called. This is this one here, and then A assigns test to S and minus K to K, and then the constructor of B is called. But here we don't see a constructor at all, because remember, the compiler can create a default constructor if it's possible, and then the default constructor will be called. And to simulate that, I have created this line here which is not there. So here I provide a custom constructor, and when we watch now here the output, you can see first constructor A is called, and then constructor B is called, and here I just assign S2 with we, just for fun. And now I delete this one as well, because this is not part of the demo. Okay, we have now constructed our B1, but two side notes. This kind of inheritance which you see here has not the word virtual, and that means it is not supporting polymorphism for functions, and also it is not a a virtual inheritance, which means it is not here on the class level. For example, we could also have the word virtual here. Then it is not avoiding this diamond problem, if you remember. So it is only supporting, with the word virtual, it would only support one shared base class. Okay, and now we jump again to the next line. It is just an outprint, and you can see it prints out b1.s. And why is this interesting? Because you can see we are not accessing s here from the struct, because in the struct b we have just s2. We are accessing the variable s from the a part, which we inherited, and the outcome is like you can see here, test. And this is expected because we already talked about struct a in the last videos, and we know the constructor here is just assigning test here. And like I said before, a is first called, the constructor of a is first called, and later the constructor of b will be called. Okay, we jump to the next line, 69, and this looks also very familiar with the line here, 58, which we already talked as well. The only difference about this line and this line is here we are using b1, which has inheritance, and here we used just a temporal object. No, not a temporal. We created a one through a temporal object. So this is really just the real difference. And let's see if there is something different happening. Again, you notice we use std_move, and like I all time say, if you see std_move, most time they convert a L value to an R value because they want use move semantics, and we can see this here. How? First of all, we have created b1. b1 means a named variable object. Named object is all time an L value. Okay, we have here an L value. We use this here in the std_move, which is a cast. We cast it to an R value, and when we have now here an R value and assigning it to b2, then we can bind to move semantics if we have a move constructor, move assignment operator, and all this kind of stuff. Okay, now we have just to check if b got a move constructor. And when we go now here to struct b, here I added something, I talk about this a little bit later. We see we have here just two variables and nothing else. You have now to check if b can implicit create a move constructor. Again, what does mean implicit create move constructor? It means the compiler can try to create for you a move constructor, but it's not all time possible because we learned there are some requirements. There's so you heard about the rules of 3, 5, and so on, and we have to check this here. In this case, we see it is a there are just two variables, and here we can indeed create the compiler can create implicit move constructor, and you can see this one here. So what does this mean? The compiler will create something like this one here. I uncomment this one behind the scene, which we can't see. Of course not like this, because this is more like user provided. Internally it creates it a little bit more in a more optimized way, but it will create something like that. And with other words, we can use move semantics here. Okay, so this one here will create it behind the scenes. So I comment this again out and we continue. But again, back here to line 65, we have now here our A1 converted to an R value, and we try to assign it to A2 to create a new object, and probably move semantics will apply. And here we learned the compiler will create implicit a move constructor, but the question is in which order? Is it created here or it is created here first? And the answer is it is created here first. It is like the constructor. When you create here this object B1, First, the constructor of A is called because we have inheritance here, and then the constructor of B is called. The similar is the move constructor. First, the move constructor of A will be called, so this one here will be called first, and everything here will be assigned to S and T if possible, and then the move constructor here will be called. So what is the move constructor here in A doing? The move constructor in A is just moving all the elements from the A part to the next object. So what is the next object here? Let's watch this again. So we have this B1. B1 has here a A part because we have inheritance, and the move constructor from A here, this one, will now move every part here to B2. And after that, then the move constructor for struct B is called implicit, but you can see the implicit move constructor here in B is nothing doing really, because there is no assignment, so the real assignment is only here on top. And we can see that. And where we can see that now, here we are trying to print out again after the move what B1.s is. Careful here, this is B1.s. This is the object which we created here. It is not the object which we are going to create here. So, and what happens there is we can read this here. At this line here, the move constructor is called. We can see this one here because the move constructor here, we have this executable. We see indeed A's move constructor is called. This is this line here. And then we know if the A's move constructor is called, the A part is doing the move semantics, so to our object B2, and then in the next line we see now we print out B1.s, and you can see after move B1.s is again empty. And this is similar like the first example here. The only difference about this example versus this example is this was now using inheritance, and in inheritance the A block was moved internally. So what we learn here with the second example is if we are using inheritance like with B1 and B2, there the A part, the inherited part, must be left in a valid state as well. And this one we can see here with B1.s, because B1.s is now also in a valid state. Remember, this B1.s is the A part. We can see this here. In A we have defined string S, and struct B has defined S2, and you can see S here, the A part is left in a valid state, empty, because we took the resources from there and gave it to the object B2. Okay, that's enough for this video, and if you have any questions like all time, write in the comment section. See you in the next video. Bye and good luck.